Hello, in this video let's look at a limit at a point, and this time we will use analytical approach, which means by hand. So we will not be looking at a graph, we will not be looking at a calculator, we will be doing all evaluations by hand. And here is the trick to doing it. If when we plug in the limit, so here is an example. First example, there will be 3 examples in this video. So the first example is, let's find the limit of x squared plus 6 divided by x plus 1 as x approaches 2. Now, if this function is continuous, then there is no gaps between anywhere in this picture, and then plugging in 2 into the function will give us exactly the same height as the limit from the left or from the right, which basically means we will be able to find the limit by simply plugging in this number, if it works. So let's try it. If we plug in 2, we will get 2 squared plus 6 divided by 2 plus 1. 2 squared is 4 plus 6 divided by 3, which means 10 divided by 3, and that's the final answer. So the answer to the first example is 10/3. And that's it. If we plug in the number and everything works, then this is already the answer. Now, in a different example, the next example, let's try to plug in the 2, just like we did the first time. And if we do this, we will get 2 squared minus 4 divided by 2 minus 2. So the top says 4 minus 4, which is 0. The bottom says 2 minus 2, which is also 0. We get 0 over 0, which means it's an undeterminate form. We don't know what that is. And that means if we see this, this means simplify first. So, if we can simplify and reduce, then that's what we should be doing first. Now, on the top here, we have the formula for the difference of squares, because we have a squared minus the b squared. And if we expand it out, that's a minus b, and then a plus b. So applying this formula, we can rewrite the top as x minus 2, and then x plus 2. Now, on the bottom, we have x minus 2, and we know that the same term on the top and the bottom cancels off. So this is really like asking us to find the limit as x approaches 2 of just x plus 2. Well, now when we plug in the 2, we get 2 plus 2, which of course is 4. And so the limit is 4. Now here's the next example. Once again, if we can plug in the number, the 1, and get the answer that is possible, that's not 0 over 0 or some other impossible form, like dividing by 0, that's impossible, then we will be able to find that limit. So if we get undeterminate form, then we need to reduce. If we don't get an indeterminate form, then we will know the answer. So if we plug in 1, we will get 1 squared plus 1 minus 2 divided by 1 squared minus 1. Well, 1 squared happens to be 1, so we have 1 plus 1, that's 2, minus 2 divided by 1 minus 1. Once again, that's 0 over 0, which is an undeterminate form. So at this point, we need to factor and try to cancel out something on the top and on the bottom. So factoring out the top, we're looking for 2 numbers that multiply to -2 and add to -1. Well, that would be x plus 2 and x minus 1. Now, the bottom is the difference of squares formula, which is x minus 1 if we factor x plus 1. Now, we see that we're still doing the limit as x approaches 1, but this time we see that x minus 1 cancels off. Notice that if we plug in 1 into the x minus 1, that turns into 0. And this turns into 0 also. That's how we get 0 over 0 in our step when we plugged in the 1. That's why we get 0 on the top, and that's why we get 0 on the bottom, because we have the factor of x minus 1 on the top and on the bottom. Those are the ones that make 0. Once we cancel it off, we will no longer be getting 0 over 0, we will be getting something else. So now we get limit as x approaches 1 of x plus 2 over x plus 1. Plugging in 1, we get 1 plus 2, which is 3, divided by 1 plus 1, which is 2, and so the limit is 3/2. And that's how to use the algebraic approach to find the limit at a point. And if you have any questions on anything, please let me know. Thanks for your time. Take care.